This is the Boötes Void, 330 million light-years of almost nothing. And the terrifying part is not just its size, it's that according to our best models of how the universe works, this void should not exist at all. In 1981, astronomer Robert Kirshner was doing something completely routine. He was mapping the universe. His team was measuring redshifts, the way light stretches as galaxies race away from us, to build a three-dimensional map of where galaxies actually sit. Redshift is the term used to describe the stretching of wavelengths of the light from an object as a result of the expansion of the universe. The greater the object's distance, the greater the redshift. And then, Kirshner and his team hit a blank, a region of space roughly 330 million light-years across where galaxies simply stopped. Kirshner was so unsure of what he was seeing that the title of his paper ended with a question mark. A 1,000,000 cubic megaparsec void in Boötes, with a question mark. Nobody went looking for it. They stumbled into the largest near-nothing in the universe by accident. The region was initially called the Great Nothing, and the more astronomers searched inside it, the worse it got. A volume that should contain somewhere between 2,000 and 10,000 galaxies contained, at last count, around 60, in a space so large the Milky Way could fit inside it over 1 billion times. To understand what we're dealing with, start here. The Sun is 109 times wider than Earth, already incomprehensible. That red circle, that is our entire solar system, inside a galaxy of 300 billion suns. And that red circle, that is our entire Milky Way, inside the Boötes Void. 330 million light-years of nothing. But here is what almost no one talks about. The roughly 60 galaxies that do exist inside the Boötes Void are not scattered randomly, as you would expect. Look at what you are seeing right now. 8 galaxies, each one completely alone, separated by tens of millions of light-years of absolute nothing. And yet, they are arranged in a line, a corridor, running diagonally through the void as if something guided them there. In a space of 330 million light-years, the galaxies were not distributed randomly. They were corralled, herded into a narrow channel. Nobody fully understands why. Now we get to the part that genuinely unsettles cosmologists. Our standard model of cosmology, called Lambda-CDM, is extraordinarily good at predicting how structure forms in the universe. Galaxies form. Filaments grow. Voids open up as matter gravitationally pulls away over billions of years. But when you run the numbers on the Boötes Void, something breaks. Some physicists argue that there has simply not been enough time since the Big Bang, 13.8 billion years, for a void this large to form through normal gravitational processes. The universe is not old enough to have produced something this empty. And yet, here it is. The most likely explanation involves dark energy. Dark energy is the force driving the accelerating expansion of the universe. It makes up 68% of everything that exists, and we still do not fully understand it.
We call that dark energy. This sounds like we know something. We don't.
The leading theory is that dark energy amplified a natural underdensity in the early universe, expanding the void faster than gravity alone could ever account for. But this raises a deeper question. If dark energy can produce something this large, this empty, in less time than our models allow, what else does our model not yet know? The galaxies that do exist inside the Boötes Void are deeply strange. Approximately 40% of them show unusual or disturbed morphologies. Some have only a single spiral arm, an extraordinarily rare shape. At least 3 pairs of galaxies inside the void are actively interacting with each other. These are not the calm, well-formed galaxies you find in dense clusters. They look like galaxies that evolved in the wrong conditions. Because they did. And there is something else, You would expect galaxies in total isolation to be slowly dying, starved of the material and gravitational interactions needed to trigger star formation. Instead, some Boötes galaxies are forming stars at up to 3 times the rate of normal field galaxies. Up to 55 solar masses of new stars per year in a single isolated galaxy. Isolation appears to be feeding them rather than starving them. We do not fully understand why. One of the most rarely mentioned facts about the Boötes Void is what surrounds it. This is not just a random gap in space. The near edge of the void is bounded by one of the densest concentrations of galaxies in the observable universe. The far edge, by another. 2 vast walls of galaxies, one on each side. Matter was not simply absent from this region. It appears to have been swept outward, expelled, and piled up at the boundaries, as if the void itself cleared the space and left the evidence stacked at the edges. What if the Milky Way sat here instead, at the center of the Boötes Void? This is our sky. This is the sky from inside the void. Watch what happens. Fewer neighbors, until almost nothing is left. In 1924, Hubble proved other galaxies existed. From inside the void, we wouldn't have known until 1960, a 40-year delay, an entire generation living blind to the universe's true scale. Every model we trust today, built on an error that should never have happened. Imagine standing on a planet inside the void and looking up. Instead of thousands of visible stars, you would see almost nothing. A handful of points of light from your own galaxy. And beyond that, pure black. No glowing band of the Milky Way overhead. No neighboring galaxies bright enough to notice. Just an empty sky stretching in every direction. A civilization born here would have looked up for thousands of years and seen nothing to suggest the universe was anything more than this single, lonely point of light. Here is the final piece of the puzzle that almost never gets mentioned. The Boötes Void sits inside the Boötes constellation. That same constellation also contains the Hercules Corona Borealis Great Wall, the single largest known structure in the observable universe. 10 billion light-years across. The same patch of sky holds the universe's most extreme emptiness and its most extreme density simultaneously, side by side, as if the universe chose one corner of the sky to place its 2 most extreme records. There is one last idea about the Boötes Void that almost never appears in mainstream coverage. Cosmological research suggests voids like this one played a critical role in Ryanization, the period when the universe's first stars switched on. Voids were the channels. The emptiness was a highway. Light from those first stars propagated through low-density regions like this one, ending the cosmic dark ages. The Boötes Void may not just be a place where nothing exists. It may be one of the original corridors through which the universe first became transparent to light. The Boötes Void remains one of the least understood objects in cosmology. Its size breaks our timeline. Its galaxies behave wrong. Its shape suggests a process we haven't fully identified. And the standard model of the universe, which has survived every other test we've put it through, still cannot tell us with certainty how this place formed in the time available. It exists. It shouldn't. And we are still trying to work out what that means. 330 million light-years of nothing. And the universe still hasn't given us an explanation.